Okay, so I've produced this short tutorial video, just to give you some support for ATA Chapter 36, those of you that are doing the online course. It's only a short video. There's just a couple of things I just want to go through and cover just to clarify. So this next picture you'll see, we're picking it up from the notes on page 4. You'll see this picture. So in the bleed system, from the engine, we take a bleed supply from one of two stages, either the 5th stage or the 9th stage of the compressor. The 9th stage is used at low engine power settings when the 5th stage air is below 32 psi. If the 5th stage air is below 32 psi, the high stage valve will be open, and that will allow 9th stage air to bleed through to supply the systems. The high stage valve is a regulator valve, and it regulates the air, the high stage air, to 34 psi. You'll notice that on the 5th stage, there's no regulator valve as such. It's just a straight tapping off via a check valve of 5th stage air. So as the engine power increases, the airflow through the compressor increases pressure, the 5th stage air pressure increases, as does the 9th stage pressure. But remember, the high stage pressure downstream of the high stage valve is regulated to a constant 34 psi. So eventually, as the 5th stage air increases, it goes above 34 psi, pushes through the check valve, and that's going to cause a high stage valve to be pushed shut, and therefore we're now using 5th stage air. The 5th stage air then passes through the pressure regulator and shutoff valve, or engine bleed valve, and that's controlled by the engine bleed switch on the control panel. The other thing we need to be concerned about is temperature. So we regulate the temperature by having a pre-cooler in the system that uses fan air as the cooling medium. And the fan air is controlled by a fan air control valve, or pre-cooler control valve, and that regulates how much fan air flows over the pre-cooler to maintain the temperature. And what we're aiming for is around about 212 degrees. Now there are so 212 degrees is pretty okay, and it's what we can work with, but we do need to provide some protection if it gets too hot. Now we have two ways of doing that. We have a 230 degrees C thermostat. Now the thermostat is a non-electrical device, it's a pneumatic device. And we also have a 255 degrees C overheat switch. Now the overheat switch is an electrical switch. And that's going to cause the PRSOV to trip off and close. The fan air control thermostat is a pneumatic device, and if the temperature reaches 230 degrees C downstream of the pre-cooler, it opens up and allows some of the servo pressure that's used to control the PRSOV to bleed off and reduce. That has the effect of making the PRSOV not fully close, but move towards a more closed position. That reduces the airflow going through the pre-cooler and will hopefully arrest the overheating of the, before it gets to the overheated critical point, which is 255 degrees C. If it gets to 255 degrees C, however, the overheat switch trips or kicks in, and it will trip off the PRSOV, which would then have to be reset. And also on the control panel, we'll get various indicator lights so that we can see what's going on. And so we're going to take a look at the resetting and how the overheat switch activates the PRSOV on the next slide. All right, so we've skipped forward to page 18 in your notes if you just want to follow and pick up this picture. And what we're going to look at is how to reset a pack if it trips, and how it's working, how that side of things working electrically, and how the packs are opened in the normal way. Okay, so this picture then, let's just get ourselves orientated to what's what. Over on the left-hand side of the picture, you'll see the P6 circuit breaker panel with 3 power supplies, 3 circuit breakers that we're interested in, providing 28 volts from various buzzes. Buzz 1, the battery buzz, and 2 battery buzzes for the light and the overheat relay. In the center of the picture, we've got our air conditioning control panel with the engine bleed switch, currently drawn in the off position. Then we've got the ACAU, air conditioning accessory unit, in the E4 rack. That contains a K9 relay and a K20 relay, or at least in the picture. And then we have our bleed air regulator, which controls the PRSOV. The bleed air regulator has 2 solenoids, the open solenoid and the closed solenoid, and they're latch-in solenoids. So if the solenoid is being energized open and you remove power to it, it will remain open because it's latched. And then to close it, you have to then energize the closed coil. So first of all, then let's have a look at a normal turning on the pack in a normal situation. So at the very top of the picture from the P6 circuit breaker panel, we've got a power supply at the very top with a circuit breaker that provides 28 volts. And the first thing it comes to out of the circuit breaker panel, it gets routed to the engine fire switch, which is currently in the normal position. From there, it comes down to the bleed air switch on the panel, on the control panel. Of course, we're going to put the bleed air switch to the on position. So it's currently drawn in the off position. So we're going to put the switch on. That means the power gets routed down through the lower set of the 2 top contacts, and again gets routed to the next step, which is the K20 start relay. We'll come back to that later, but we'll just assume they're not doing an engine start right now. From the K20 start relay, the power then gets routed down through to the next hurdle, which is the K9 overheat relay, and we'll assume the K9 overheat relay is in the normal position as drawn in the picture. So from there, from that K9 overheat relay, the power is routed to the open coil on the solenoid valve. Boom, we've got a ground signal there, boom, boom, boom. And therefore the bleed air, or PRSOV, is energized to open, and the valve will open. Okay, so everything's happy days and we're flying along and everything's good. Now what happens then if there's an overheat situation picked up by the overheat electrical switch? So down at the very bottom of the picture, on the right hand side, you'll see the overheat switch set to 255 degrees, currently drawn in a normal position, i.e. non-overheating. But if the pack overheats and detected by that overheat switch, it goes to the overheat position and a ground signal is provided right there. Now going back to the circuit breaker panel, at the bottom circuit breaker, there's a power supply from the 28 volt DC bus. That gets routed from the circuit breaker panel, goes straight into the ACAU to the overheat, to the coil of the overheat K9 relay. And we've got an overheat condition, so from the coil of the overheat relay, it comes down and along through the overheat switch, boom, 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 goes to ground, energizes the K9 overheat relay. So in the K9 overheat relay, you'll see 3 sets of contacts. They're all drawn in a normal position right now, but when that relay is energized, all those 3 sets of contacts are going to go down to the energized position. So all those 3 sets of contacts drop down to that lower position. If we look at the top set of contacts, that is now going to divert the power. Instead of going to the open coil of the solenoid valve, it diverts it up and along to the closed coil. Boom, we've got the ground signal there. That means the PRSOV is energized, closed, and the PRSOV will close. Now just going back to the K9 overheat relay, we need to look at the lower set of the 3 contacts, because they have energized when those lower set of contacts energize, the power supply that's come from the lower circuit breaker through the coil of the overheat relay, currently energized because of the ground signal provided by the overheat switch. But if we follow and trace the line going up to the lower set of contacts, you'll see that they've now closed because it's energized, and the power is then routed along to the overhead panel through the trip reset switch, which is in the closed position right now, and to ground. Therefore, the K9 overheat relay is latched in the energized state. Obviously, when the valve closes, the PRSOV closes, the temperature is going to drop because there's no more air coming through. So the overheat switch is just going to reset itself, going back to normal. So you're going to lose that ground signal that was provided by it, but too late, because the ground has now been provided via the trip reset switch. The other thing that can cause the overheat K9 relay to operate and get a ground signal is actually through the overpressure switch as well. So it's called the K9 overheat relay, but it can be energized because of an overheat condition or an overpressure condition. So if we want to reset the pack and try and get them restarted, what we have to do is pointless turning the pack switch on and off. That will not do anything at all because the K9 relay remains energized. What we have to do is push the trip reset button on the panel. That will cause the ground signal to be lost because you interrupt it. The K9 relay will de-energize, obviously as long as there's no overheating or overpressurizing, which it wouldn't be. And that will then put the upper set of contacts back to divert the power to the open coil. Okay, so when you do a reset, you push the trip reset button, that interrupts the ground signal to the K9 relay and it resets. When else will the pack valve close? Well, if you look at the inside the ACAU, you've got the K20 start relay. So currently in the normal position, but during an engine start, the K20 relay will energize. How does it do that? Well, if the bleed switch is switched on, power is routed to the K20 relay. It goes through the lower set of contacts, as we explained just now, but it goes up to the coil of the K20 relay. We're seeking a ground signal to complete the circuit. So if you follow the line up, comes to the engine start valve. When the engine start valve is open, as it would be during a start, those lower set of contacts will close. Boom, boom, boom. We have a ground signal, and the K20 relay energizes. When the K20 relay energizes, the power is now routed to the closed coil of the PRSOV, and it closes during the engine start. Once the start cycle is finished and the engine start valve is closed, we're going to lose the ground signal to the K20 relay. The contacts drop down to as they are in the picture, and the power gets rediverted back through the open coil of the PRSOV. You don't need to do a reset. It automatically resets because the K20 relay doesn't latch. And of course, the other thing is if we have an engine fire and we push the engine fire switch, then that will just bypass everything and puts power from the top circuit breaker, boom, straight through to the closed coil, boom, and causes the valve to close. And the only way to reset that is to reset the fire switch and put it back to normal. Okay, so hopefully that's clarified the situation in terms of pack tripping and resetting and what causes it to trip. How do we reset it, and what other occasions the pack will be commanded closed? Obviously, if we have a fire or during an engine start, or of course if we have the bleed switch off. If we have the bleed switch off as per the picture, then the power from the top circuit breaker through the fire switch, it then goes and gets routed through the off switch contacts and straight through to the closed coil on the valve. So that's how you open and close the valve normally. Okay, good. So that's just about wrapped it.